The differential effects of carbon dioxide on ammonium and nitrate assimilation explain ecosystem responses to carbon dioxide enrichment. Ecosystems where ammonium is the predominant source of nitrogen from soils such as rice paddies, forests, and marshes show consistent stimulation under enrichment. Ecosystems where nitrate is the predominant nitrogen source, such as grasslands, become deprived of protein at elevated carbon dioxide concentrations and show only small changes in productivity. As atmospheric carbon dioxide concentrations rise and plants dependent upon nitrate as a nitrogen source become deprived of protein, the nutritive value of plant material will suffer. Wheat, rice, and potato provide 21, 14, and 2% respectively of the protein in the human diet. Wheat plants receiving normal levels of nitrogen fertilization had 10% less grain protein, 10% smaller loaf volume, and 10% lower scores on quality indices under carbon dioxide enrichment. Similarly, grain protein in rice and tuber nitrogen in potato declined about 10% at elevated carbon dioxide concentrations. Changes in plant nitrogen levels also affect other herbivores. Herbivores are plant eaters. Not only do plant protein concentrations decline at elevated carbon dioxide concentrations, but green tissues accumulate higher amounts of compounds that interfere with animal digestion. Herbivores, plant eaters, and carbon dioxide-enriched treatments increase their consumption of foliage to compensate for its diminished nutritional value and palatability, but the herbivores still experience lower growth rates, lower fecundity, and higher mortality. These factors lead to an overall decline in herbivore populations at elevated carbon dioxide concentrations. In summary, number one, most plants acquire their mineral nitrogen through root absorption of inorganic nitrogen ions from the soil solution. Number two, elevated carbon dioxide concentrations inhibit nitrate assimilation into protein, and plant nitrogen status plummets. 3. Herbivore populations decline at elevated carbon dioxide concentrations.